Hello. So today we are going to learn about log properties, but before we do that, we need to figure out one more thing about writing logs. So first of all, let's go back to before spring break, and we talked about E. E was a number. E is used in finances quite a bit when you're calculating compound interest. It's also found in nature. So they've got this number E. Now, just like pi is 3.14, and you can memorize that, E is approximately 2.71, and it just keeps going. Okay, so E is just a number. So if E is just a number, if I have e to the x raised equals 70, I can rewrite that as a logarithmic function. So I can say log, and then E is my base, so base E, and then these two things change place, of 70 equals x. Except I wrote a 2, not an E. Why do you think I did that? Okay, E. So that's perfectly correct. However, if you ever have log-based E, there's another way to write that, and they call this the natural log. And the way they write it is ln of 70. Okay? So anytime equals x, so that would be the same thing. So anytime we have log base E, it's the same thing as the natural log. And I know we say natural log, but it says ln, and it's derived for something in French, and so they would say log natural, but in a nice French accent. Okay, so that is what the natural log is. So it's just another, it's just like log. Just think of it as when you see ln, it's just the natural log, so it's log-based E. And we can find values for those just like we did with the regular logs. We can put it in our calculator. So the first one is the natural log of 50. We're going to round to the 10,000th place, so we know that's 4 decimal places. So in your calculator, over on the left, kind of in between the 7 and the 4, is this ln button. So if we do the natural log of 50, whoa, totally wrong number. Natural log of 50, we get 3 point, and 4 decimal places would be 9120. So we have 3.9120. Okay, now let's find the natural log of 88 just for practice. The natural log of 88 would be 4.4773. So 4.4773. So again, in your calculator, the natural log button is over here on the left between the 7 and the 4. So you hit that, whatever number you want. Okay, so now we are going to start using this natural log mixed in with our regular log. And you don't have to, it's really nothing different, it's just log base E. Okay, so here are log properties, and this is something you probably want to get in your notes to refer to. So at some point, pause the video and write this down. But if we have log of base B of m times n, we can rewrite it as an addition problem, log base b of m plus log base b of n. So we're separating the m and the m with a plus sign. Okay, if it is division, we have log base b of m divided by n. We have log b of m minus log b of n. So it's a subtraction problem. So when it starts as division, we can rewrite it as subtraction. And then if we have an exponent, whatever that exponent is, here it's n, we can move that to the front and we can rewrite it n times the log of base b times m. Now, why would you do any of this? Well, there are some applications to this, and there are some problems that we could do. However, we're in this crazy online school situation, and so I'm just going to tell you the reason I am teaching you this is because there's a question or two that will come up on the ACT about the properties where you have to rewrite something, and that is simply why we're doing it at this time. Now, if you are super bored and you're intrigued, I invite you to Google what you could do with it, but for right now, we're just trying to rewrite these. So the first thing that we're going to do, and we'll do more of these again on Monday, but today we want to rewrite an expanded form. So it's giving us something that's over here on the left, and we're trying to convert it to something that's over here on the right. So on the first one, we have log of 6 times 11. Now first, notice two things. One, there's no base. Remember, if there's no base, they're assuming it's the base of 10. Just like when we have a square root, they're assuming there's a 2 there, even though you don't write it. Okay, So when there's no base, we're assuming there's a 10 there. All right, so that's the first thing we need to notice. The second thing is the 6 is multiplied by the 11. Well, if we look up at our properties, multiplication we can rewrite as addition. So this is going to be the log of 6 plus the log of 11. Done. That's all we're doing. We're just rewriting them using the properties so that you can successfully answer a question on the ACT. All right, the second one, again, it's log base 10 again, so they don't write the 10, it's just invisible. This one is division. Quotient means division, right? So when it's division, we rewrite it as subtraction. So this would be log of 2 minus log of 5. And I wrote 2 first because 2 was on the top. When you're subtracting, the order matters. When you're adding, the order does not matter. All right, let's try number 3. Now, number 3 is interesting because you got variables in here, which is not that big of a deal, but one has a power. So how are we going to deal with that? Well, it starts as being division. So that means that it's going to be log of x minus log of y to the 6th. But we can rewrite this part more because it's an exponent. So if you look back at these exponent rules, that exponent moves to the front. So this first one doesn't have an exponent, it stays the same, so I have log of x minus the 6 goes to the front, so it's going to be 6 log y. All right, on the second one, or number 4, most of you probably want to jump to and just say, okay, I know what that is, it's log 25 minus log of 2, which you're sort of right. But when we have just numbers, if we can rewrite them as in this form, some number raised to a power, we need to do that to completely simplify it. So how could we rewrite 25 as something raised to a power? Well, we have to know, like we did the other day, we have to know these numbers and recognize, oh, 25 is really 5 squared. Okay, so this we can rewrite as, oh great. Hold on. Okay, let's see if it works now. This one we can rewrite as, if I can spell log correctly, as log of 25 is really 5 squared. So we're going to write 5 squared over, now 2 we can't convert, so it's just going to be 2. So because now it's a quotient problem, it's going to be the log of 5 squared minus the log of 2. But I can fix this one, or I can rewrite that. So that's going to be 2 log 5 minus the log of 2. Okay, let's try this again. On number 5, we've got numbers in there. So how could I rewrite that? So if you think about our list, well, 49 is 7 squared. 27, do we see 27 on the list? Oh, yep, 27 is 3 to the 3rd. So I'm going to rewrite this one as log. Isn't this nice that my pen isn't working? Okay, log 7 squared, hold on, over 3 cubed. So now when I rewrite that, because it's originally a division, it's going to be minus. So I have log 7 squared minus log 3 cubed. And then I can rewrite it moving the exponent. So its the final answer is 2 log 7 minus 3 log 3. And that's our final answer in expanded form. Okay. Now we're going to try this again for the natural log. Remember, natural log is log base e, but we don't need to rewrite it as log base e. We can just leave it like this. So that's going to, now because it's multiplication between these two things, remember? So it's really going to be, when we multiply, you add. So it's going to be the natural log of x squared plus the natural log of y cubed. But when we have the exponents, remember, we can move them to the front. So it's going to be 2 natural log of x plus 3 natural log of y. And that is our final answer. So even though we're not writing the word log, it's still the same thing. Okay, number 7, this is division. So it's going to be natural log of m cubed minus, for division, natural log of n to the 5th. move the exponents, so I have 3 natural log of m minus 5 natural log of n. Sorry, I should have picked different variables with the natural log, huh? N and natural log together doesn't look good. All right. Couple more and then we're done. This we want to write as a natural log, or rewrite it in expanded form, but we've got numbers, so we have to figure out how we can change them. Okay, 64. Well, 64 we could write it as 4 to the third, or we could do 8 squared. Well, we want to figure out the one that's got the smallest base. So the one with the smallest base would be 4 to the third. So that's the one that we're going to use. So I'm going to rewrite this as, when my pen starts writing, the natural log of 4 to the third over 5, because 5 I can't rewrite. It's division, so it's subtraction, so it's going to be natural log of 4 to the third minus the natural log of 5. But this one has an exponent, so it has to come out front, so I have 3 times the natural log of 4 minus the natural log of 5. And that's my final answer. Okay, 2 more. Now, what if it wasn't a natural log, or what if it wasn't log base 10, where we don't put that invisible 10 there? Well, we can have it. It's still the same. This right here is multiplication. So when it's multiplication, it's addition. So I'm going to rewrite this as log base 5 of a squared plus log base 5 of b to the 7th. But again, I can rewrite it because those exponents need to move to the front. So this is 2 log base 5 of a plus 7 log base 5 of b. And that is our final answer. Okay, let's try one more where the base is not a natural log. The base isn't the invisible 10. So this one is division, so that means subtraction. So I'd say log base 4 of x cubed minus log base 4 of y. But I've got an exponent, got to move it to the front. So I have 3 log base 4 of x minus log base 4 of y. And there's your final answer. Okay, next time we are going to get ones in expanded form and then move them back to the condensed form. So stay tuned for that.